In this project, I aim to extend Hawkins and Goodman's insights about iterated reference games to the color reference dataset created by Hawkins et al. In 2017. The first goal of the project is simply to evaluate the color reference dataset's suitability for the iterated reference experiments based on a few key metrics that indicated strong convention formation. The second goal is to recreate the rational speaker and listener agents that were trained to play the color reference game and test the output they generate based on these metrics. In doing so, I aim to evaluate how successful an accurate artificial agent is at producing human speech patterns. Hawkins and Goodman found that human speakers tend to develop local conventions to refer to certain concepts or objects during repeated communication, in addition to the global lexicon that most competent speakers of a language share. Their experiment results came from a two-player game where one player, adopting the role director, instructed a matcher to rearrange a set of ambiguous shapes according to an order that only the director could see on his screen. On this slide, you see the director's screen, and this round number indicates that the same two players would play this game for several rounds, allowing their iterated references to form. In many ways, the color and context dataset is pretty similar to the Tangram game. The color reference game gets two players who don't know each other at first to repeatedly play a game where one player instructs a listener to click on the correct target color out of 3. The Tangram experiment captured 3 main aspects of linguistic convention formation. First, the arbitrary choice of referring expression from a set of possible alternatives. Second, the stability of the convention once it's chosen. And third, the reduction in complexity of expressions over time. The main metric used for stability and arbitrariness was entropy. If the stability and arbitrariness of the data of utterances were high, then we would expect to see a higher scramble entropy value than true entropy value. And this trend does hold for both the English color reference and Chinese color reference datasets, suggesting that convention formation in some way is taking place here. However, the results on the reduction metric are much more mixed. We do see a decrease in speaker utterance length over rounds of the game, but it's not a very clear trend. Though I do want to note that this anomaly at the end, where the utterance length spikes at round 50, is partly due to speaker and listener exchanging greetings in the last round. The second reduction matrix also shows a mixed result. There isn't really a clear trend in part-of-speech frequencies across round numbers, although we do see a very slight decrease in the percentage of determiners used. So the results suggest that the suitability of the color reference dataset for the iterated reference is pretty mixed. The second part of the project, which I'm working on now, focuses on recreating the speaker and listener agents from the Hawkins et al. 2017 color and context paper. On this screen, you see the model sketches that allowed Hawkins and co. to generate pragmatic speaker utterances and then also create an artificial listener agent who could model different potential utterances and based on that select the correct target color out of 3. I'm currently working on reaching the target accuracy scores that Hawkins et al. Achieved in 2017. However, once that's complete, the 3 main modifications I'd like to make to that design is first, to calculate the stability, arbitrariness, and reduction metrics on the speech generated by the agents in the model. Second, I'd like to incorporate listener utterances as well as speaker utterances while training the base speaker and listener models. Third, I aim to track changes in the expressions chosen by the speaker over time after a listener unsuccessfully chooses a target color based on a certain expression. That's the end of my presentation. Thank you very much.